Welcome back. We're going to do a little more shell method. This is a problem similar to one I found in a previous edition, so it's not really one in your book. But this is one that they actually give you the graph, so I'm not going to worry about talking about that too much. But it looks like this. And it's y equals, and I think I would expect you could do this one without a calculator or without the graph being given to you. Let's see, it's about there. And this is y equals 8. And they tell you they do, and you can figure this out yourself, but where they intersect when x equals 2. So, and it's also bounded by the x-axis, x equals 0, y-axis, x equals 0. So you can see that it is bounded on this side, on this side, on this side. And we are going to rotate this around the y-axis. So we'll do it with both methods. Let's start with, let's see which one I would probably do. I mean, again, like I said, I would keep my rectangle vertical unless you have some compelling reason not to make it vertical. So there's our region. Oops. So we'll call that's going to be dx. And when you make it vertical, the thing is nice, you have to rearrange your equations. Like this given equation right here, we'll have to rearrange it if we want to do disk on this one. So we've done sketch, arrow, rectangle, differential, SARD is complete. We are ready for our work. So let's do shell first. So shell means 2 pi. What are the bounds? They are stacked up vertically, and they start at 0 and they stack over to 2. Okay, and so gotta get our minds back in the shell mode again. Our P is the distance the rectangle is from the axis of revolution. And look at that, it's the same, or sorry, it is, of course, that one's the same, but as the rectangle moves left and right through the region, that distance is always the x-coordinate. Remember, I kind of told you that it's always going to be, it's going to be x or y as long as you're revolving around the x or y axis. And since it's revolving around the y, it is x units from the y-axis. Height is a little trickier on this one. What is the height of that rectangle? Well, we need to find, we do top minus bottom. So what is that top y-coordinate? It is 8. We need to multiply this. So times 8 minus the bottom y-coordinate, which I circled in green there a moment ago. That one. Well, that one's kind of depends, right? So the bottom y-coordinate is that distance. It's changing as the rectangle moves through the region. And what is it? It's just the y-coordinate. Well, the y-coordinate, as we see here, is of that curve is x squared minus 4. So we got to be careful with our parentheses here. That'll do it. It is 8 minus your current y-coordinate. Your current y-coordinate is expressed with x squared minus 8. Again, I don't want to spend a ton of time on integrating. I think this one is doable. This would be 8 minus x squared minus 4. Again, I know you can skip ahead, so I won't rush too much. This would be negative x cubed plus 4x. Is that right? Yes. So now we integrate, and that becomes negative 1/4 x to the 4th plus 4 times 1/2, or 2x squared. I hope that's okay. It was 4 times 1/2 x squared. 4 times 1/2 would be 2. There's our bounds. Now, 0 bounds don't always result in 0, but here it will. Especially trig, that doesn't happen, as we've seen many times. But it would be 0 plus 0. I don't have to plug it in perfectly. And so we end up with 2 pi times, is that -4? And that is 8. So that becomes 4, which gets us to 8 pi. 8 pi. Okay, that's about as messy as an integral I'm probably going to make you do from here on. So shell wasn't so bad, really. Let's see what the other method's going to look like. I'm going to make a quick sketch. Oh, I didn't do the right colors so well. Switching things up a little bit here. So we're revolving around the same axis, and now it needs to be perpendicular. So this can be disk, right? Because there's no inner radius. The inner radius is always 0. This coordinate again is 2, 8. This is at 4. I didn't label that over here. Didn't really matter. But it's 4 because the y-intercept is 4. And so we're going to do disk. And if you call disk washer, that's fine. It doesn't matter. Because disk is a special case of washer when the inner radius is 0. So for disk, we just put a pi. Our bounds. What are the bounds? You think we're getting used to this? They are from 4 at the lowest up to 8 at the highest, right? And it's like, is this really going to be the same thing? Well, I hope so. Hope so. Hope we get our 8 pi. So the inner radius is right there. It's 0. But the outer radius is, if you can see that green, the outer radius is just the x coordinate, right? And this happens a lot with disk and shell. But, I forgot my D of SARD. That's pretty bad. dy. Sorry about that. And I really rely on that to tell me you can't use x. You need something in terms of y. So what is x in terms of y? Well, here we go again. This is the reason we don't like to flip our rectangle. And it's really not that big of a deal here. But just you have to rearrange. And yeah, you normally put a plus or minus here, but we don't need to because we're only looking at the right side of this curve, the parabolic curve there. So we don't really need the plus minus. So hey, this is actually fine. This becomes y minus 4 all squared dy. No big deal. Wow, I really hope this is right because I didn't do this version before. No. Let me just double check. Yeah, that looks good. Okay, so 4 to 8, this just becomes y minus 4. So you might see that disk on this one is actually easier. There's a little bit of work to rearrange, but look at the integral is going to be a lot nicer. 1/2 y squared minus 4y. We're hoping to get 8 pi. Now we are going to have to plug this in, all of these in. So 8 squared minus 4 times 8. Be careful with these parentheses. 1/2 4 squared minus 4 times 4. So let's see what we get. That becomes 32. That's 32. That's weird. Okay. This becomes 16. 8. Yes, this is going to work. 8 minus 16. That's -8, but there's a negative there. Those cancel, and so this becomes 8 pi. Since that first part canceled, there's something that we could have done. Think about that. Some kind of something I could have done to simplify it, probably a little bit easier. But anyway, it works. Disk and shell get us the same answer. Here, disk was maybe a little bit easier looking at all the work. I don't know, actually, because we had to rearrange. So about the same. But sometimes it's a ton easier, and we'll see some of it. Or sometimes it's really near impossible to do it by hand with the other method. So I want to do one more of these before we call it a day. And this one I think is in your book on page 462, number 19. And I'm happy to talk about these. If you have questions, feel free to reach out to me and we can keep talking about these. But I'm just kind of giving you a basic run through a few examples. And as always, I don't do the examples in the book, so you can consult those as well for extra help. Okay, so this is page 462, number 19. And they give you the equations y equals x cubed, x equals 0, and y equals 8. So let's try it with both. Let's try shell first. So y equals x squared, y equals x cubed, hopefully you remember, looks like this, kind of like tangent. X equals 0, of course, is the y-axis, so I'll just kind of darken that. Y equals 8, horizontal line. So we quickly see our region is right here. And we're going to rotate around, they tell us, the x-axis. Okay. We got to do one. Actually, you have to come back for the next video when I'm going to, because I haven't rotated around an axis other than the x or y. And when you don't do that, that's going to make your p a lot different, p-value. So we should try that. Come back for the next video, or there's some examples in the book you can consult too. Okay, so if we're going to do shell, which we'll start with, it'll be, whoops, that's wrong. Let's do that, yeah. Shell, parallel, will be a horizontal representative rectangle. You don't have to make it solid, I'm just showing off the iPad stuff there. Okay, sketch, arrow, rectangle, differential. So let's do shell. Shell starts with 2 pi. Bounds 0 to 8. I'm still giving you a little pause for that. I'm not going to get into the slicing. You could do the slicing again. It goes from 0 to 8. We need p-value. P-value, usually it's just x or y, and when you're revolving on the x or y axis, and it is y here. Because, I will show this, how far is that rectangle from the axis of revolution? Well, right then, you know what? Happens to be the exact y coordinate. But if the rectangle went up a bit, it would be the exact y coordinate there. If it went down a little bit, it'd be the exact y coordinate there. Wherever the rectangle is, the distance to the x-axis is the y coordinate. So P is y. What is H? Well, H is, I'm running out of colors now, I'm going to use black, okay. That distance, right? What is that? Well, you're going to always do right edge minus left, or top minus bottom, or right minus left. So here, if someone says, hey, you're a runner, right? Well, I run too. Let's see how much more you ran than me. And they go, okay, I ran, let's see what this would be. I don't know. I'm just going to, let's say, okay, let's do it up here. They said, I ran 15 miles today. How about you? You're a runner, you say? You said, I ran 0 miles. Okay, well, how much farther do you run than them? Well, the distance, 15, right? 15. So here, it's the x coordinate minus 0. The x coordinate minus 0, so that just gives us the x coordinate. Green. It's just the x coordinate. What is the x coordinate? Well, we do have to rearrange this. but that's just x equals the cube root of y. Or maybe it'd be easier to see it as y to the 1/3 power. We kind of prefer that when integrating. So this is times, times y to the 1/3. No squaring in the shell world. So this is y to the 4/3. That's all we got to integrate. Just a single term. We'd have to mess with the radicals, fractional exponents, but we can do that. So 7/3, put a 3/7 out front, evaluate it from 0 to 8. And what do you know? I pick nice numbers. Because 8's cube rootable, this becomes 6 pi over 7. And we're just going to do 8 to the 7/3 minus 0 to the 7/3. Well, fortunately, 0 to any power is 0. And 8 to the 7/3. I can even do this in my head. You can do it in your head. What's 8 to the 1/3? Cube root of 8 is 2. 2 to the 7th. I count on your fingers if you want. 2, 4, 6, 2, 4, 8, 16, 32, 64, 128. So this is 6 pi over 7 times 128, which best we can do is 768 pi over 7. That's our volume. Okay? All right, one more before we call it a day. And you might want to watch the other video. I'm not going to do it until tomorrow. Let's see, eraser, get rid of that stuff. My great example of the two runners. Okay, let's do a quick sketch again. There we go. Quick sketch again. Let's do it in black. So there's a region revolving around the x-axis. And so we need a vertical representative rectangle. It's always, you could always tell it's going to be the opposite of the shell. So this will be vertical. So sketch, arrow, rectangle, differential, tiny x. Okay, this is called, this is going to be washer. Again, you can use the washer and disc interchangeably, those names. Probably the best way to go is to call them all washers. Washer and disc, we start with a pi. What are the bounds? Well, actually, this one, we got to figure out what this is, right? Because we know this is y equals 8. This is y equals x cubed. Well, when would they intersect? At 2, right? Because 2 cubed is 8. So again, I'm trying not to pick two horrible values. So what are the bounds going to be? 0 to 2, right? So we slice our way through. So these are horizontally aligned from 0 to 2. What is our... So now we have to do inner and outer radius. So the outer radius is the edge of the rectangle that is farthest from the axis of revolution. How far is that top of the rectangle from the x-axis? Imagine you were to fall off the top of the rectangle and landed on the x-axis. Maybe the x-axis has got pillows, you're fine, or something like that. So, well, let's see. If you were to fall here, you would fall from y equals 8 to 0. That'd be 8. If you were changing the representative rectangle to be here, the top of the rectangle is also at 8. Here, it's at 8. Here, it's at 8. The rectangle, no matter which one you pick, it's at 8. So the outer radius is simply 8. And we're in the washer world, you square your radii. Inner radius. The inner radius is the edge of the rectangle that is closer to the axis of revolution. If we look at all these examples, and if you don't need to do multiple examples, it's changing. So it must have a variable in it. We're only permitted to use the variable y. X. I'm only permitted to use the variable x. Although I'm tempted to want to use y because that distance, it's growing from here to here to here to here. but it's really just the x coordinate, right? If you were to fall from here and someone said, how far did you fall? Well, you would say, well, I was at 6 feet off the ground and I landed on the ground, so I guess I fell 6 feet. You fell the y coordinate. So that's what that distance is, always the y coordinate. So what is the y coordinate in terms of x? Here it is x squared. So x cubed, sorry. So it's minus x cubed, but you better square it. That's how we do things with washer methods. You square the outer and inner radius. And as you go back and forth from shell to disk, it is tricky. So take your time. Okay. Now I'll do a little simplifying. We get 64 minus x to the 6th. And you can skip over this if you like. 64x minus 1/7 x to the 7. It's nice when you plug in a 0 as one of your bounds again. So 64 times 2 minus 1/7 is like, can these really be the same answer? That would be 0. That would be 0. So what is 128 minus, oh, wouldn't we do 2 to the 7th a little while ago? It was 128. 128 over 7 going to be? Well, guess what? It works. If you got a common denominator, I'm really not going to do it, but if you got a common denominator, it would be 896 over 7. And so when you subtract those, you, I guess I'll just show it, why not? 896 over 7, and what do you know when you subtract those? You get the anticipated, the expected, the desired 768 pi over 7. Never has that looked so good. Probably never seen it before. Okay, we're done. Disk and shell and washer slash disk. You might be thinking these are kind of similar. Well, the one I'm going to do next time is not going to work with disk or washer, and that will happen actually maybe more often than I've shown. But I wanted to start with some more basic examples. Hopefully that's helping you. Come back next time for the third video as we wrap up 7.3.